welcome to the third lecture of trigonometry. Right, last time we had seen one question, how to find out the basic trigonometrical quantities sine, cos, theta from the triangle, how to find out the trigonometrical quantities when one is given, how to calculate the other. Today we have another set of the problems, most of them deals with the proof type. These sums are specially for the standard tan. Let us see how to solve them. So the first question we have, the value of cos theta is given to us. So if we start solving, right, if we rearrange this, we get cos theta as 2 by 10, right, 2 goes here, so 5 2s are 10, so it is 1 upon 5. And since we have the value of cos theta, can we calculate value of sin theta and tan theta? Yes, we can calculate sin theta. How? Using a square relation. So using a square relation here, if we make sin theta as a subject, right, 1 minus cos square theta, and this will be under root. So simplifying, 1 minus 1 upon 5, that is whole square. So 25 minus 1, 24 by 25, right? Square root of 24 is 2 root 6 and square root of 25 is 5. I hope you know how I found out the square root, right? 24 can be written as 6 into 4 and the square root of 4 is 2. That is I have taken outside. So I got the value of sin theta, first answer. Then next I want the value of tan theta. Tan theta, it is sin upon cos, right? Substitute both the values. So 2 root 6 upon 5, this is the value of sin theta. Cos theta, it is 5 upon 1 upon 5. So the answer is 2 root 6. Answer for the tan theta is 2 root 6. A simple solution to the first question. Next, question number 3. Again here, if we rearrange, we can get the value of cos theta. After finding cos theta, we can similarly find out the value of sin theta. It is under root of 1 minus cos square theta, right, from the square relation. So 1 minus 9 by 25, LCM is 25, 25 minus 9 is 16, 16 by 25, that is 4 by 5, correct? So value of sin theta we have, yes, sin theta and cos theta, only two things we need. Now let us use them in that substitution. So 3 into, what is the sin theta? Sin theta is 4 by 5 plus 2 into cos theta. Cos theta is 3 by 5 upon 3 sin theta minus 2 cos theta. Let us solve further. So this will lead to 12 upon 5 plus 6 upon 5 whole divided by 12 upon 5 minus 6 upon 5, right? So LCM is 5, numerator will become 18 and denominator becomes 6. Since LCM is 5, we can cancel denominator from the upper part and from the lower part. Now if we simplify, this reduces to the 3. So answer for this question is 3, right? Then the next question number 4, right, it is a prove that. So generally we take a left hand side, the one which is longer, that one we select. Now again here what to do, how to solve such prove that type of the questions? Very simple. If you don't have a clear idea, the one basic step which you can do is convert the given quantity into sine and cosine form, right? That is what the most basic thing you can do. I'll write down here in the box, convert to sine and cos form. So here also I'll do the same thing, right? 1 minus cos square theta, cos x square. What cos x square can be written as? Cos x square is nothing but 1 upon sin square theta. Now here, what is 1 minus cos square theta? If I rearrange the square relation, then 1 minus cos square theta is nothing but sin square theta into 1 upon sin square theta, and that is equals to 1, which is the RHS. Hence, the proof is Done. Simple question. Let us see the fifth one, right? Again, as per the basic rule, right? If you don't understand from where to start, what to do, the first most important thing which you can do is convert into sine and the cosine format, right? That will help you to solve the question. So cosec can be written as 1 upon sine theta. Then in the numerator 1 plus cos theta. Then we have cosec, which is 1 upon sine, and then cot, right? Cot can be written as cos upon sine theta, right? Let us simplify further. So 1 plus cos theta upon sine theta multiplied by, here the denominators are same, so numerator can be combined, right, upon sine theta. This is in multiplication. Numerator resembles a plus b, a minus b. So what is the formula of a plus b, a minus b? A square minus b square. If we use this identity in the numerator, right, numerator becomes a square minus b square. Sine into sine is sine square theta, right? So 1 minus cos square theta is again sine square theta. We have used here in the previous question, right? We know that from the square relation we conclude that 1 minus cos square is sine square theta. So that we cancel it, it is 1, which is equals to RHS. Hence we have obtained the required proof, right? Then the next question, sixth number. Let us start with the sixth question. This is LHS we take again, right? So in the LHS we take LCM, right? So LCM here just will be a cross multiplication. I'll write down question first, so it will be easier for you to understand. Now cross multiplication, just LCM in such cases is obtained by cross multiplication. So 1 minus sine A, 1 plus sine A upon a plus b, a minus b. So that is a square minus b square, minus sine A plus sine A cancel. 2 upon 1 minus sine square is cos square A, and 1 upon cos square is sec square A. So again the simple solution to the answer, right? Then let us do the seventh one, seventh question, right? Again we have cosec, right? We can take out common in the numerator, and in the denominator either we can convert it into the sine format or same way we can proceed. So let us try. There are multiple ways this question can be solved. So numerator cosec A I have taken common, right? And then the remaining part is cosec A minus 1 plus 1 upon cosec A plus 1, right? Let us simplify. Again cross multiplication is required here, right? To take LCM, cross multiplications you do. If these are not the digits, then the simple method is just to cross multiply. Denominator will be a square minus b square. Simplifying further, in the numerator plus 1 and minus 1 gets cancelled. Cosec A plus cosec A is 2 cosec A. So cosec A dot 2 cosec A, right? Now again if you recollect the identity here, which identity? This one. I'll write down here. Cosec square theta minus cot square theta is equals to 1. If you recollect this identity, what is the value of cosec square theta minus 1? It is cot square theta. So in place of theta we have a here, so we'll write down a, right? In the next step we'll convert it into the basic sine and cosine form. So it will be 1 upon sine A, 2 remains in the numerator. This is another cosec A, so another sine A in the denominator. Cot square A, it can be written as cos square A upon sine square A. Sine square A gets cancelled. Remaining part is 2 upon cos square A, which is nothing but 2 sec square A, and that is nothing but the RHS. Hence we got the proof, correct? So simple it is. Continuing with the sums, right? 8th number. So if we solve the 8th number, right, taking LHS, let us convert into sine and cosine form. So tan square is sine square A upon cos square A minus sine square A. Taking sine square A common in the numerator, minus 1. Taking LCM, cos square A, correct. 1 minus cos square is sine square A. This cos square I have shifted with the sine square A. So 1 minus cos square is now again sine square A. Sine upon cos is tan sine square A. We got the answer. So the simple trick to solve such prudent type of the sum is to proceed, right? To think, to start. As you make your pen work, as you start solving the sum, definitely you will recollect the steps, or definitely you will attain this final solution. It may be needed that you may need to give 1, 2 or 3 try, but if you keep trying, right, these questions are very easy to solve. Let us take next question, 9th one. Again I take LHS. It is up to you, you select LHS or RHS. Most of the times the LHS side is a complicated one which can be simplified to the right hand side, which is always or most of the times in the simplified format. There are only very few questions in which we select right hand side and then we obtain the left hand side. Otherwise, most of the times we take left hand side and then obtain the right hand side. So LHS is square root of square A plus cos x square A, correct. So again converted into sine and cosine form. Sec can be written as 1 upon cos, cosec can be written as 1 upon sine. Cross multiplication, sine square A plus cos square A upon cos square A dot sine square A. Sine plus cos is nothing but 1, square relation, right. So if we convert this into numerator, it will be sec square A dot cos x square A. Square root get cancelled with the square terms, remaining is our answer. That is what the RHS is, right? No wrong. What is wrong in it? Let us see. Sec square A plus cos x square A, cos sine square. So here we want sec A plus tan A. So how do we obtain sec A plus tan A? Okay, so we'll do some modifications in the solution, right? That is just from the here, from this step. So this can be written as 1 upon cos A dot sin A. If we remove the square root, this can be written as 1 upon cos A dot sin A. Now, if we refer to the question, we want tan and cot. So what it will be? So here 1, right, 1 can be written as cos x square. 1 we can convert again into sin square A plus cos square A, right? We can replace it. 1 can be written as sin square A plus cos square A, simple. Denominator as it is. This is an art of rearrangement. Then dividing denominator separately with both the terms. Cos A dot sin A, correct. Now here sin gets cancelled, here cos gets cancelled. Sin upon cos is tan A plus cos upon sin is cot A. So here is the answer. So rearrangement has to be done, right? After some steps you need to give a pause, think a little, have an idea of what is given in the right hand side or what you need to obtain on the right hand side, and based on that you proceed. Let us look at the 10th sum. 10th sum has sec a plus tan a in the right hand side. So again selecting the left hand side of the equation, sec a minus tan a. So here this one is very simple to solve. 1, it can be written as sec square a minus tan square a. Wherever you see 1, right, you can replace that 1 with a square relation, because you know all the 3 square relations are in terms of 1. So you can replace 1 in terms of square relation. Here also I replaced 1 with a square relation. So here a square minus b square, it can be written as a minus b, a plus b, right, sec a minus tan a. So here simple sum, we got the answer, right? Yes, here we have the answer. Last sum for today, right, 11th one. That is again we can take LHS side and solve. So taking the LHS part, cot can be written as cos upon sine, tan can be written as sine upon cos. So that is, if we take again a cross multiplication upon sine a cos a, right, denominator we have already obtained, but numerator we want cos. So convert sine into the cos format using a square relation. Let us do. Sine can be written as 1 minus cos square a upon sine a dot cos a. So here it will be cos square a minus 1 plus cos square a, sine a dot cos a. Cos square 2 cos square a minus 1 upon sine a dot cos a. So here we have the answer, right? We'll continue in the next class. See you.